My name is Jim Lindsay. I'm the product manager from Sigmatech. I'm going to obviously present SigmaTube. Before I do that, my background is I actually worked for the very first bar for SolidWorks when it came out. That was computer-aided technology. You guys probably know who those guys are. I did that for about 7 years, and then I moved on to SigmaTube, or Sigmatech, and I've been there for about 10, 11 years now. And just in the last few years became the product manager. But so we have a long history with SolidWorks, but I'm not a certified user of any kind. Unfortunately, I have to learn every one of them now. So Pro E and X. So what is SigmaTube? SigmaTube is a complete tube cutting solution that has seamlessly integrated inside SolidWorks. And again, I can't call it a gold partner today because we haven't applied for a gold partner. And there's also some constraints on the gold partner. You have to have the ribbon bar and all that stuff, and we're in the process of just now switching over to a ribbon bar interface and some of the other criteria that you have to be gold partner. So that version will be coming out hopefully in about March. But again, it's designed for tube cutting, for lasers, plasma, and water jets. We've done a few, I believe, as well. And it also does the nesting part of it, but also again creates the NC code for those machines. Now, the one thing that's been, like I said, I've been at Sigmatech for about 10 and a half years, and we've been for 20 years. We're actually celebrating our 20th anniversary this year. We've been a leader in the plasma laser flatbed cutting for many years. In fact, Stella is one of our customers. Now, what kind of machine do you guys have? Okay. So we do a lot of all the 2D profile cutting processes today, and then a few years ago, we started on the path to doing tube cutting. And it's strange over the last several years to watch as you go to the machine trade shows. Almost every machine maker is now making a dedicated tube cutting machine. It's really starting to take off. And so we, even though it's not flat, which is what we've been doing, we decided to jump into this arena because it's still sheet metal. It fits the niche of our customers. The new version also, we can do cross sections, and I'll show you some of the cross sections in a bit, but structural steel shapes like beams and channels and stuff like that. We've expanded from just going from round and squares or rectangles to now hexagons, which is actually gives you a different type of couple different solutions to try to solve when you're doing hexagons, and also then tapered parts or tapered tubes. Might be 10 or 15. Think of a light pole. It's a hexagon, but it's also might be 20 inches at the base and 10 inches at the tip. And so we actually now drive that, and actually recently did a project where it's a dual head tube cutting machine. So there's two heads cutting from each side of on each side of the part. And depending if they're symmetrical parts, it will use two torches, and turn off one torch if it's just doing a singular cutting. So we did a really good, that was at Trinity in Houston, where we did that product, or that installation. Okay, a little bit more about Sigmatech. Like I said, we're celebrating our 20th anniversary this year. We're founded in 1993, obviously, with that. We're headquartered out of Cincinnati, Ohio, which is obviously nice for me. We were just talking about that. It's 9 degrees in Cincinnati today. So I like that being here. We have offices all over the world. Originally, we were founded in South Africa. Our corporate headquarters, though, has been here for almost 19 and a half of those, probably 20 years. So right after they formed, they moved here, and it became a U.S. company. Actually, our sister company, MECAD, is the largest VAR out of South Africa to sell SolidWorks. So we have a sister company. So we're very tightly associated with SolidWorks from a company standpoint. And again, some of the other places that you see there, we're roughly around 12,000 users. Unfortunately, I can't do 2 million like or whatever that SolidWorks said the other day, but we're shooting for it. But who uses Sigmatech products? And no, this is not just a tube product. This is all of our family of products. You'll see some obviously household names. Some of the good ones there are, that are SolidWorks users are Vermeer, Rolled Alloys. I know he uses SolidWorks. Caterpillar, or not Caterpillar. Well, Vermeer I know does. Rolled Alloys does. Gale uses SolidWorks, I believe, and a few others I'm sure there. Now, when it comes to not only driving or working with different customers, obviously when we're doing NC code and running machines, we need to run and work with a lot of the different machine manufacturers out there. And that's something that we've done very well on the profiling side, is we've partnered with just about everybody and can drive just about every 2D cutting process. And we've taken that technology and things that we learned there and work with all these tube manufacturers as well. These are just strictly, every one of these companies has a dedicated tube machine. You know, everything from the $1 million type machine that Trump does, it's a Trump 7000, and the Mazak, I think it's called the Fabrigear. The BLM ones, those are very high production, very costly machines. Ultra, which is a U.S.-based company, they're out of Dewey, Oklahoma. They have a really neat, I have a picture of one of their machines here coming up. So, I mean, a lot of different manufacturers there, in different types of controllers. And we have a dedicated team of engineers just for this product, where they go around. They don't do anything necessarily even with SigmaNest. They concentrate just on this product. Okay. The picture on the left is the Ultra machine. That's a plasma machine, and then you've got the laser on the right. And I'm going to play a short video. This is going to give you this customer here that I'm going to play a video on. It's about 3 minutes or 2 minutes, I think. It's a company called CRD. CRD is a SolidWorks user in Southern California. It might even be Hawkridge. I don't know if you guys are one of their dealer or not, but they make a machine for this, but they also make the monster body frames for out of tube. And so this is one of our first customers with this product, and they made a really nice video showing this, so I'm going to play that. Hopefully give you a good idea what tube cutting really is. That's etching, by the way. You might do some marking on the part. So give you a little, just a little idea of what a tube machine is and you know, the process of cutting tubes. Let me go back to my slideshow. Now, again, like I was saying, the types of shapes, we started out on our first release, basically we could only do the rounds, but we've expanded that to tubes, free-form shapes, angles, channels, tapered tubes, structural beams and stuff. And we're working on now being able to nest half parts on a tube. So, you know, if you take a full tube, I only got half of a round part. You can nest them together as kind of kind of like a C-clamp or something like that, you know, the two pieces together. So that's kind of the next evolution of this. Now, before I forget to mention, the difference between, there's a few other products out there that do this. The difference between mainly what they do and what we do, and I'm not going to obviously name the other competitors, so, but typically what they make you do is they make you draw the part as a 3D model, and then go through a sheet metal flattening process. Then they make you NC code that, and then you have to, you know, obviously refold it and send it back out or post it out. Obviously that takes a whole lot more time. If I have to take a tube it's truly a tube, it's not a sheet metal tube, and then you have to flatten that out. We don't do that. We work completely inside SolidWorks with the model. And you're going to see, because we're probably going to have plenty of time, I'm going to go into a live demonstration a little bit too, where we'll look at some parts and you'll see an assembly being nested real time. But and you'll see that we'll actually apply reference coordinate systems and all that stuff automatically. We don't make you go in and assign a bunch of properties and stuff to get it to do it. Okay, so again, why use Sigma Tube? It's fully integrated with SolidWorks. It's fully associative. So again, everything just, it eventually becomes a gold partner. If you make the change of the model, it's going to let you know when you go back into the Sigma Tube part of it. It's going to say, hey, this nest is out of date. You know, do you want to update it? And it will allow you to re-nest very quickly. Generating toolpath, as you'll see, is very easy. Optimizing material, and that's been, we call it the 4 M's within SigmaTech walls is things that we do. It's the 4 things that we concentrate typically saving the company, a company money. Then the first one is material efficiency. So reducing the amount of scrap material. So that's the first and foremost thing that SigmaTech was founded on when we did our nesting product and then we brought that obviously to Sigma Tube. So again, we're going to do not only linear nesting, but we're going to rotate parts and put them together like a jigsaw puzzle. I'll show you an example of that in a little bit. So we'll interlock parts together, things like that. But then we take it to the next step, the second M, which is motion optimization. We're going to look at how to reduce the amount of cycle time that we can reduce, so the fewer amount of pierces, common line cutting, things like that. All the things that we learned on the flat side, we have now transferred into this product as well. And I'm going to show you a live, at the very end I'll show you, because I know it was also one of you guys' concerned here at Hawkridge, was the fish mouth example, you know, modeling concerns. What we will do is we'll actually help you compensate for bad model design. And I'll show you what that is, because nobody really takes the time. If you do a 5-axis model, but you're really only got a 4-axis machine. You know, I can't take the head of my head of my cutter and lay it over and do the taper of the part. So I got to figure out how to compensate for that, because I may not have that access to do that. If I have that, great, we'll do that too. But a lot of machines out there don't. Again, like I started to say, there's a couple different machines. Those newer machines, those the Trump 7000s and the BLMs, they're all 5-axis typically. The 3 or 4-axis machines, you know, you got X, Y, Z, and then the rotation of the tube is the 4th axis. The one thing that those are typically on a flatbed laser in a lot of cases, where what they do is they take the table and they move it off, and you've got a rotary truck inside the bed. So it's the same 2D flat laser that you might be running with a rotary truck attached to it. That's a very common type of machine we run into. Do you guys have a tube machine, by the way? Okay, you're looking. Okay, I was wondering if you maybe had that on your mitts or something. Okay, and then obviously 3D simulation of the cutting process. In new to 4.0, we're now doing full work order management and inventory management, which is, we've had obviously that in our standalone Sigmas product for years. What that means for you is, okay, I've got an MRP product or an MRP system that derives my orders for my business. I send, the typical way that you might handle that today is somebody obviously enters the order into the MRP, a paper report is printed out, sent down to the nesting shop. They take that same information, re-enter it in, and try to cut all the same parts. But somebody might take a 9 and make it a 6, or, you know, instead of 65, they make, 56 or 102 or whatever, fat fingers. So what we do is we'll connect right with the business system, send it through a transaction table, talking to your MRP system, and automatically populate our database for work orders or jobs that need to be processed. And so we'll know which parts need to be cut. We'll know which parts, what the quantity. If you might have a split order, you might have an order of 50. The nester only could do 50 because that's only got, he has an order for 100, it only does 50 because he's got only so much material. So then we keep track of that in the database so that later on when he gets more material in, he knows he can go and nest the rest of those parts. And he's still got 50 more to cut. So we'll keep track of all that whole process. Okay, so this is an example of a part. We have end cuts on each side of the part and what we call loops or intercut, your holes inside your part. They don't have to be just holes. They can be any kind of contour, obviously. We'll automatically recognize that, and you're going to see that in the next one of these videos. This is what I was talking about, material utilization. Notice that this part here, you can see that right there, I got two parts that automatically flip together and put together as to save material. If I was doing strictly a linear nesting, I would have a lot of wasted material in there. So true shape nesting. Okay, so your question when you walked in was, can we do the fish mouth? This is a perfect example of a fish mouth and an example of bad modeling. Oops, didn't mean to do that. Right there in that gap you see right there, you have of a model that was designed not to fit into the other tube really properly because they didn't, the way the process is going to cut that, it's not going to cut the material correctly on a 4-axis machine. On a 5-axis machine, I probably would have been able to cut that fine. But on 4-axis, I really want this. I want to get that welded in there properly. And again, I'm going to show you that here in a minute, how we would accomplish that. Again, without the user of SolidWorks having to really do anything different than they're doing today. We're going to compensate for that automatically. And then the simulation process. So I'm going to do another short video. This is actually of Sigma Tube, the nesting process. There's no audio on this or music, but move my thing around. So what we're doing is we're actually opening a part. Trying to get my mouse out of the way. I have a wizard that it's going through right now, and it's automatically picking the center point generation, going in and checking some settings like kerf offset, lead-ins, my lead-in distances and stuff, and I'm going to go ahead and pick what type of nesting algorithm I want. You don't necessarily have to do it because it will remember what the previous settings were. And then what we're going to do is we're going to step through that. It's going to pick how many parts I want to do. We're going to actually tool path it. And then it's going to generate an automatic length, or it's going to put in a length of material that he wants. In the future, like I said, this video was done before the inventory was put in. We would automatically select from remnants and other types of material that we'd have. From here, it's doing the nesting process. Obviously, I didn't modify it to make it look a little faster. So there's the nested parts together on a simulated tube or stock. And you notice if you look close, you'll see that the parts are interlocked and twisted around so they fit together. And I can actually not only simulate it with just motion, I can actually look at the G code as I play it through. So I can actually look at the NC code as well. Now I can do a full machine simulation as well, but it's usually most people don't. They just look at the head. Now there, it's locking the head or locking the tube into rotation, and it's moving the torch in an XYZ location. I can do it that way, or I can keep the head at a spot and have the tube rotate back and forth for me. So I can do it either way. You get two different results on that hole. You know, one's tapered, one's not. You know, we can always adjust that on the fly. So I think you get the idea of that. Okay, so again, as you saw in that video, we did automatic and manual lead-in placement, or we saw automatic lead-in placement, but I can go around and I can move the lead-ins in any place. And again, if you're new to the cutting process, you don't want to just pierce right on the line that you're cutting. You want to pierce in, cut into the material, and then cut around the profile. If you obviously pierce right in, it's going to blow a little nipple on the part, and it's not going to be a good quality. Loop customization. Again, what I can do is I can, like I was telling you, where the part was not rotating, or the tube wasn't rotating, I can go in and on each contour set how I want the tube to rotate or not to rotate, and I might get slightly different answers. Again, if I rotate the tube, I'm getting a taper on the hole. If I keep the hole straight and just cut around it, I can take a tube and shove it through it. Okay, if I move the part around, I'm actually going to get a taper on that hole. So, depending on what you're looking for. I can reorder the cutting sequence. So it's going to look at and do different cutting sequences, but I can also then drive, I can go in and say, no, I want that hole to cut before that hole, and I got a little tree that I can move things around, kind of like in SolidWorks. I can move things up and down in the process. Marking. Everybody, I mean, etching's big, and it's been for years on the you need to mark the part with a part number. You need to put a material identification number for inspection, whatever it may be. You can add those to the model as a sketch. We'll pick those up and just automatically assign a marking process to that. Okay, tabbing. Tabbing is holding the parts together. Now, you were describing a different tab, but I don't think this is actually what you're looking for. This is tab holding the part from falling apart, you know, the tube. As you start doing them, you may want to keep the parts together till the end and then basically do a snap apart at that point. And we can control the different sizes and manually move them and replace them in different spots. You were going to take a picture, I'll let you take a picture of it. Again, this is what's new to version 4. Officially, hopefully, get released in March, version 4. But this is basically the full remnant management like we've had in SigmaNest for years, is being able to work with remnants. And again, we've had customers on the SigmaNest side that justify the whole purchase of a system, of a nesting system, based on just getting rid of and managing the remnants. So again, a remnant is you nest on a tube. They come in, 10, 20, 40-foot lengths. You use, let's say you're doing a 20-foot length, you're only using 10 foot of that bar, you still have 10 foot that's usable, and I can put that on the shelf. SigmaNest will know when it goes to nest, hey, let's go use that remnant first, get rid of that so we have less scrap. Okay, and then work order, I kind of explained that whole process of connecting to the MRP a little bit ago. The other thing that's with all of our products, we kind of design the products to be scalable. The idea of scalability is you can start small, grow into it as you need. Not everybody out of the gate wants to do work order management or is going to have the ability to do work order management or inventory management. So you can start with just the nesting and NC portion, move up to these other products. And then once you got those, it's kind of a manual work order process, but then now connect it to your MRP system as a kind of a third integration. Now in SigmaNest, there's probably more than that. There's probably 4 or 5 different levels that you would do that with. And then I'm going to go into live demonstration. This is just a selfish plug, which probably this whole presentation has been. But these are some of the other products that we do. And again, I'm the product manager for all these, so I have to speak about them, or at least tell you about them. SigmaNest, which is our 20-year-old product, it's been around for a long time. It's a very mature nesting product. We're getting ready to release version 10. I know I've been saying that for a long time, as my customer is over there laughing. It's getting close. What? I'll talk to you that off-site on about 10. It's coming. Solid Nest will also be, we'll release Solid Nest. Well, the good thing about SigmaNest, the new product, we have a whole new nesting engine. A few years ago, we hired a couple PhD guys. One was his background was writing nesting algorithms. That's what he did his thesis in and all that type of stuff. They've been working for about 3.5 years rewriting our nesting engine from ground up, which is already a leader in the industry, but we're now getting a 3% gain on yield on material over the current one, on average. And then SolidNest is the gold partner product that we have that inside SolidWorks. It does the same nesting. It's not at the same maturity level of SigmaNest. It's not aimed to do everything that SigmaNest does, but it does do some really nice nesting capabilities. And then SigmaNest 3D is a brand new product that I hope to kind of get rolling this year. It's a 5-axis laser cutting software. So think of a car panel door, and we're going to be cutting those parts out. SigmaBend is a bending solution. Also works with SolidWorks. We can import native SolidWorks files and do press break simulation in C code. SigmaTube, which is what I just showed you, and a brand new product we acquired last year, written specifically for SigmaNest, but we actually acquired the company. It's an MRP software, and I'm working on a bunch of new stuff that will link SolidWorks assemblies and bill of materials and import it right into the MRP system and not having to regenerate the bill of materials inside the MRP. So there's a bunch of cool things that I'm trying to tie in from that side. The MRP software is geared for small sheet metal fabrication shops. It's not a SAP Oracle type based system. So, okay, so before I go into a kind of a live presentation of SigmaTube, any questions from what I just showed you? Well, SigmaTube is what I just showed you. That's the simulation tube. We don't do any tube bending. I keep getting asked, but man, I'm scared of that one, to be honest with you. It's different types of bending calculations and stuff like that. So I won't say never, but it's not in the foreseeable future. Is there any products out there that do that you know of? Yeah, I mean, I get asked about that at the shows. There is? I keep getting asked, and I haven't done any research to see what's out there. And so basically what I do is I just open an assembly that has a bunch of different parts, different size tubes, couple different size shapes. So you see some square tubes and some round tubes. And that's really all I've got going so far in here. And what I'm going to do is I want to show you the 4-axis modification. So this part here is all they did was slice it. So it's not going to really form to another. It's not necessarily a fish mouth per se. I should have probably brought up a fish mouth, but this will give you the idea of what we're talking about. If I cut that on a 4-axis machine, I'm going to get a cut around this whole outside edge on most softwares, but then I'm going to get a lip that's sticking up on the top of here, okay? And that's never going to seat correctly into another part. So I'm going to go ahead and say open that part, and we'll get this in here. Now, this was the older way. I actually have the coordinate system, reference coordinate system saved. I don't necessarily need to do that with the current version because we have a tool that automatically finds now the reference or the center of the tube. But if it for some reason can't, this is the way you do it. You do a reference coordinate system, apply it to wherever the tube is, apply what is axis typically along the tube on most machines, and we're off and ready to go. But again, on most parts, you don't have to do that. I have a couple ways to go through this. I have now on the feature bar, I can use my ribbon bar. Again, this is all fairly new. It's not even officially released on this part yet, but what I'm going to do is I'm going to go into this interface, and I'm going to, I can either find my reference coordinate system, or again, I can. This one? Oh, I'm sorry. Okay. Okay, I'll bring this down. Is that better? You can't see that up there, but there was a pull down. Let me see if I can bring that down a little bit too. There you go. Okay. We'll see if we can resize this just a little bit more yet even. Yeah, I walked in here, there was no sound on the computer I was supposed to be using, so. So again, I can go in through and I can pick if I'm not using the auto coordinate system, I can just pick that and it will automatically cut the paste and the name of the coordinate system I'm using for my reference. I can go in here and again, where I showed you earlier some of the toolpath settings, and for some reason that does not want to come up. So we'll just go on. I'm going to go ahead and create the toolpath on this thing, and you're going to see, again, what I was talking about. If I rotate this thing around, what we do is we automatically figure out along that top edge where the cutting path is, but then on the bottom part, we start switching to the inside radius or the inside arc automatically. And so that's what we call 4-axis modification. So that part now will actually fit into the mating part that it needs to in most cases. And that's a big thing. I don't know many of our competitors that do things like that. They make you model the thing completely correctly, or good English, completely correct, which is always going to take more time on the SolidWorks side and do it. So hopefully that, depending again on the machine you're having. You know, again, if I was on a 5-axis machine, it's going to lay the head over and cut it completely with the bevel, and you're going to be fine. So from there, I've got things like I was telling you, sort. My thing going behind here. I apologize on that. Something's not, none of my dialog boxes are on these. It could be. Yeah, we're using Windows 8. I'm not sure what that is on Windows 8, but let's see, move. Yeah, it's just on that dialog box. Interesting. I should have a dialog box with a little sort thing that can drag up and down. But this is where I would go and make those modifications to the sorting and or the reorder. Or I can pick a lead in. I can say move lead in, and I can pick the lead in here and move it, you know, to there or wherever I need it. And in a case like this, I actually may want to move it to a spot here, because now I'm actually, as I move around to this side, it's just a straight line. And then I typically do want it on that side, because I want to cut the hole, and as I come around, I don't want to have to cross over the hole as it's cut. Otherwise, the head, well, we do height sensing, so we'll know, and it won't let the head fall into the hole, but there are cases where if you cross over something, it's just going to drop the head into the hole and damage, obviously rip the head off the machine. So we should take care of that automatically. So, and then obviously it spun this part around, which I'm not necessarily sure why it did that, but it should have went from a straight shot right to here. But this post may have been set up where it's got to do a rewind. On some machines, you can only go so far in a rotation, then it has to respin back around. And I may have a post that has a limitation on that, so it won't let me do some of that. So, adding tabs and stuff like that. But then again, here I can set my post, and this is a Hank Wang post, which probably shouldn't have that process or problem. And then simulation, I can go in and simulate live. And I've got the full machine on here. That one is not simulated really correct, because that machine head should be back to the machine, because there should have been clearance there on that machine. That's just a standard model that we throw in there for the machine. But what we do is we take an STL file of the machine. You model it up in SolidWorks. We output an STL of the machine and with the right coordinate systems, and that's how we get a reference of what the model looks like underneath. And it's low impact on the system. Then if I try to put a huge machine in there and just to simulate a tube, it's probably going to kill most of the guys' machines. On the nesting side, if I go back to discard change assembly, on here again, what I can do is I can do a quick path assembly, which allows me to automatically go through the process as a wizard. I don't actually have to touch anything. It just automatically goes through all the steps as defaults and does the process for me. Now, if it can't find any material or anything, it's going to tell me that, but it did find material there. And it nested both tasks. So there's my tube, my round tube. I've got another larger tube here. Oops, sorry. So there's a larger tube, even a larger tube yet, and then my square tube. So it automatically, with just one click of the button, very quickly nested different material types, different thicknesses, different shape types in one shot. And got a nest out that quickly, and all I would have had it done is come over here and say post, and it would have made the NC code. And then, like I said, I can just go through if I want to double check it, and do the NC simulation. Oh, I know what that is. That one I do have an error. That's a post error. That's not, it can't find a path. I didn't correct that. I wasn't expecting to have to use my computer. But there I'm seeing the tube cut with the NC code on the tube as well. doing there? He's doing something a little weird. We'll ignore that, okay, guys? It's beta. This is beta 4. But it is pretty much that quick to run through a simulation and get a nest of an assembly out and ready to go. So, about 15 more minutes. Any questions or comments? Hopefully it was worth coming, spending an hour with me. On the solid nest, I do. On Sigma Tube, I haven't packaged it that way. I mean, could we? Sure. What would they do with the nest after they? Is it just for quoting purposes?
So they don't want to write any code, but they want to optimize how many tubes.
Okay, and that's what we're doing with why we did it with solid nest. It was to give the engineers the ability to go, what if? You know, just bring up a part, make a change to it, see how it nested. For more or less I could probably do that for this if that's something that it wouldn't be very hard for us because everything is modular based in the way we do it. We could turn off the NC code part of it fairly easy.
I've had 5 or 6 customers now, so
Yeah, I mean, give me your card before you leave and I'll give you a call. That would probably be very easy to do for us, and we just have a lower cost. Nesting only version of tube that I could see where that, because again, we did that just recently on the solid nest side because we wanted to give the power just to play what if with a part and see how it nested. I never really thought of it applying it to here, but if you think there's a market for that, I'm willing to talk and learn. Yeah, I'm showing you assembly, but when that first one I did, that was in what's basically a part mode. So, and actually we do sell the product as Sigma Tube part, where all they do is single part programs. So that's even cheaper than you go into the nesting level, and then then true shape and all that. So yeah, we do have just a single part programming mode. But again, no nesting obviously on that. So you have to have it in an assembly. Obviously, you guys don't want to hear this as a SolidWorks reseller. We do allow, if a customer came to us, so let's say they use Inventor or Pro E or something, they don't want to buy a seat of SolidWorks, we do have the ability to sell them a OEM version of parts or parts and assemblies, no drawings, at a lower fee, basically, to get them running Sigma Tube. So there's basically an OEM version. We're at 2 different levels, but again, we don't sell many of those. We try not to sell that when we're especially working with a reseller. We will be cognizant of that, trying not to point that out. But we did offer that mainly for the fact that we have a lot of NX customers, Inventor customers that they don't like the word SolidWorks anyhow when you try to sell it in there. So we did come up with a compromise. It still says SolidWorks, obviously, when it boots up, but it's just a stripped down version for modeling purposes only. Any questions, comments? They didn't tell me necessarily how to finish this up, but I think there's the form there on your chair. Let me know. I mean, this is my first time doing one of these breakout sessions, so I wasn't sure too much what to expect. I actually only went to my first one yesterday. It's my 8th year here, but I've always been down in the partner pavilion, and that's it. So, I wasn't sure how to put this thing together, quite frankly. So, please be honest with your feedback. If you would have liked to see it more technical, whatever, I'll try to do better next year, and not so salesy. Oh, I mean, as far as taking something and wrap it around a tube?
Or like a poor guy that just wants to use a grinder to cut out the cracked top.
Now, you know, we do have customers that, believe it or not, in India and China where they take it, they use our demo software, they nest, and then they plot out the one-to-one scale of that, and then they go out with a hand torch over the paper and cut out parts. I don't understand it, but we do have customers that do that. But no, we haven't. I mean, that's probably not the kind of user we're marketing toward. Is that low-end hand grinder or hand torch type customer? The software ranges, you know, probably from the 5,000 to 20,000 range. By the way, it's not. You know, when you're getting up to the top, the high end with the full nesting work orders and stuff, we're not. We're a high production type shop is where you're looking at our software. Company that's going to be doing a lot of tube cutting. And like I said, it's really taken off over the last few years. We're finding customers that used to make parts in a lot of different ways, and you know, a lot of hand drill or, you know, bridge ports and stuff. They're now they're going to tube cutting machines because it's just more cost effective. So the tube machines are really exploding out there, and I think we're on the front end of answering those questions. So, like I said, this was our first CRD, I think, started this 3 years ago with our first implementation. So this is been a work in progress for a few years. So, but I think this year will be a big year with it because it's really matured a lot. Well, thank you. I appreciate it.